Hello everyone. Today I'm going to talk about second order reactions that follow second order chemical kinetics. Um I'm going to derive the rate constant equation. First, let me take a second order reaction. See, this is a second order reaction. Two molecules of A reacts and produces a product. Let me write its rate equation. The rate equal to minus dA by dt. With respect to reactant, I'm writing the rate equal to dP by dt equal to it is directly proportional to concentration of A power 2. I'm talking about second order reaction, hence I'm writing 2. So the rate is a proportionality constant K is introduced, which is known as rate constant. Then let me take a second order reaction of this type, that is two different reactants are involving. This gives a product A plus B. This gives a product. I'm writing rate equation, rate equal to minus dA by dt equal to minus dB by dt. With respect to product, the concentration of product, change in concentration of product with the time, of course directly proportional to a concentration of A and a concentration of B. Let me say power 1, here also power. I assume a second order reaction of this type, that is order with respect to A is 1, order with respect to B is also 1. So I recall that a rate equation is constructed by doing experiment. Then you have to introduce a proportionality constant. K, A and B. If this equation in this equation, the concentration of A and the concentration of B, they are different. What if the initial concentration of A and B are same? The concentration of A and B are same, then you will have this equation, this rate equation for this reaction. When the concentration of A and B taken for the reaction is same, then you have to write this rate constant, rate equation, because the concentration of A and the concentration of B will be same. Right? Okay, let me take the first rate equation, that is before that Let's say I have that is 2a that gives product. At time 0, at time 0 that the reaction is not started at 0 time, the product will not be formed. The concentration of product will be 0. And then the reactant concentration, the concentration of reacting molecule, reactant, let me assume A mole per liter. After some time, say at time t, X mole per liter of product is formed. How much remains? The concentration of A unreacted A molecule will be A minus X mole per liter. Right. If it is clear, then we'll take this equation, this rate equation for this type of a second order reaction, minus dA by dt equal to dP by dt equal to K concentration of A square for a second order reaction. I'll take minus at time t, the concentration of A, that is reacting molecule, concentration of reactant is A minus X. So D, I'll write A minus X divided by dt equal to, at time t, the concentration of product, that is the concentration of product is X. So I'll write dx by dt equal to K. I know at time t concentration of A reactant is A minus X square. So either you can take this two pair or this two pair to integrate. I'll take this two pair, that I'll take dx by dt equal to K A minus X square. Rearrange that 1 by A minus X square dx and K dt. I'm going to integrate. And this is, I can write A minus X inverse 2 dx K dt. I know a formula that integration of x power n dx equal to x power n plus 1 divided by n plus 1. That's the formula. Apply this formula, and this is A minus X. Okay, let me. For A, this is X, right? This is X power minus 2. X is A minus X power minus 2 plus 1 divided by minus 2 plus 1. Then this is not simply X, it is A minus X. Therefore, you differentiate A minus X and write in the denominator A minus X. If you differentiate with respect to X, will give A is initial concentration, so constant becomes 0, minus X is minus 1. So I'll write minus 1. Okay, that's all. You'll have some integration constant plus, okay, then K, if you integrate dt becomes t. Here also you'll have integration constant. So this 2, for the 2 constant, I'll write 1 constant over here. Then how this look like? This will become, this equation will become this is minus 1, this is minus 1, so plus 1, this is A minus x inverse 1 kt plus c. So this is 1 by a minus x equal to kt plus c. So I want to find out the integration constant. Let me turn the paper. Right, okay. This is so the limits are applied here that when time t equal to 0, I know that the reactant, the product concentration is 0. No product is formed when time equal to 0. No product is formed. So product concentration is 0. That is x is 0. So therefore, if you substitute, it will come 1 by a equal to c. Therefore, you now know its constant value. Now substitute in this equation. 1 by a minus x equal to kt plus 1 by a. So k equal to 1 by t, 1 by a minus x minus 1 by a. Or you can write k equal to 1 by t. Just you take LCM a minus a plus x. This x a cancelled, a into a minus x. So therefore k equal to x by a t a minus x is the rate constant equation for a second order reaction. When the second order reaction of this type, or when you take the reactant concentration same, a and b should be taken same concentration to carry out the reaction. You will get a rate constant expression of those type of reaction. Okay, let me take a second. Let me take. Okay, I'll make another video